In this video, I'm going to go over the evens for systems applications, and then you go back and try the odds. The odds are very similar to the problems I'm going to show you on the evens. So, starting with number 2, it says for a school play, 340 tickets valued at $810 were sold. Some cost $2 and some cost $3. How many tickets of each kind were sold? This is very similar to the word problems we did back in Unit 2. When you have two variables, you're going to have two equations. So, some cost 2, I'm going to call those x. Some cost 3, I'm going to call those y. And then I have two totals here. I have a total of 340 tickets, and then I have a total of $810. So, one equation is going to represent how many tickets I have. The other equation is going to represent how much money I have. So when dealing with tickets, you don't have to include how much money. What I mean by that is the number of tickets, x, plus the number of tickets, y, is going to equal 340 total. Then for my second equation, when I use the money total, that's when I'm going to include how much they're worth. So if some costs $2, I have 2x, and some costs $3, I have 3y. That is going to give me my total of $810. So the first equation is representing how many tickets I have. The second equation is representing how much money it cost. From here, you get to choose whether you want to solve using substitution or elimination. If you want to use substitution, I recommend getting x or y in the first equation alone since they don't have a coefficient. They don't have a number in front of them. If you want to use elimination, this one is already set up because my x's line up, my y's line up, and my equal to signs line up. Because of this, I am going to use elimination. But again, you get to choose the method you want to use. So, in order to eliminate a variable here, I need to multiply the top equation by something. I can multiply the top by -2 to get the x's to cancel, or I can multiply the top by -3 to get the y's to cancel. I'm just going to use -2 since it's a smaller number. When I do this, this becomes -2x, -2y, and -680. The bottom is going to stay the same. I'm not going to change the bottom at all. Now I'm ready to eliminate. So I'm going to add this together. My x's cancel, and -2y plus 3y is 1y. -680 plus 810 is 130. So I have 130 of the tickets that cost $3. I want to know each kind of ticket though. So now that I know that y is 130, I can plug this back into my original equation and solve for x. To get x by itself, I just subtract 130, and x is 210. These are super easy to check because your answer should make sense with the situation that you have going on. 130 plus 210 is 340, so I know it works. Let's look at number 4. On number 4, it says, on vacation, Ashley and Tracy took turns driving. The distance that Tracy drove was 115 more than the distance Ashley drove. Together, they drove 235 miles. How far did each girl drive? So, I have two people here. I have Ashley, I'm going to use A for Ashley, and I have Tracy. I'm going to use T for Tracy. The distance that Tracy drove, so T equals 115 more than what Ashley drove. So T equals 115 more than means 115 plus, than Ashley means plus Ashley, plus A. Together, they drove 235 miles. So my second equation is going to deal with their total, which means t plus a equals 235. At this point, you get to choose whether you're going to use substitution or elimination to solve this. If you want to use elimination, you can move the a over and line up your variables. This problem is already set up for substitution because t is already alone. So I'm going to use substitution here. But again, you get to choose. Since t equals 115 plus a, I am going to take 115 plus a and plug it in for t. That means this second equation is going to become 115 plus a equals 235. The 115 plus a is representing t, the a is representing Ashley. From here, I can solve for a because a plus a is 2a. Then I'm going to subtract 115 over, and 2a equals 120. When I divide by 2, a is 60. So Ashley drove 60 miles. To figure out what Tracy drove, I'm going to plug that back into my original. So t is 115 plus 60, which means Tracy drove 175 miles. Again, to check this, you can make sure that it equals your total. 60 plus 175 equals 235. So I know I did it right. You always want to make sure that your answer makes sense at the end. All right, let's look at number 6. On number 6, Chad and Andy went shopping in the same store. Chad bought 4 shirts and 2 ties and spent $104. Andy bought 3 of the same shirt and 3 of the same tie and spent $96. What was the cost of 1 shirt? A lot of people think that your 2 variables are going to be C and A for Chad and Andy when you start this problem. However, we're not actually solving for Chad and Andy. We're solving for the cost of a shirt or a cost of a tie. So instead, we are going to have one equation representing what Chad bought and one equation representing what Andy bought. I am going to use S for shirts and T for ties, but you can use whatever variables you want. Chad bought 4 shirts, so I'm going to call that 4S, and 2 ties, so plus 2T. His total was $104. So his 4 shirts plus his 2 ties gives us 104. Andy bought 3 of the same shirt, so 3S, and 3 of the same ties, so 3T, to spend $96. These are our 2 equations. Now we're trying to solve for the cost of 1 shirt. You can use substitution or elimination on this problem. I am going to use elimination since my S's are lined up, my T's are lined up, and my equal to signs are lined up. Now, in order to get this to eliminate, I need to do some multiplying here. Since there is nothing I can multiply by 3 to get 4, or by 2 to get 3, I have to multiply both equations here. So I am going to try to eliminate the T's since I am only solving for the shirt. I want S to remain. In order to do that, I'm going to multiply the top equation by -3. I just took it from right here. And I'm going to multiply the bottom equation by 2. I just took the number from right here. By doing that, -3 times 4S is -12S. -3 times 2T is -6T. And -3 times 104 is -312. For the bottom, when I multiply across, 2 times 3S is 6S. 2 times 3T is 6T. And 2 times 96 is 192. Now I'm ready to eliminate the T's. When I add these together, negative 6t plus 6t cancels, and I'm left with negative 6s equals negative 120. When I divide both sides by negative 6, the cost of one shirt is $20. Moving on to number 8, we're to our coin problem. And if you look at 7 and 8, they're both very similar because they're both dealing with coins. When you have your coin problem, it's super important that you remember how much a coin is worth. So let's talk about that for a second. If I have 1 penny, remember, is equivalent to 1 cent. That is 0.01, not 0.1. If I have 1 nickel, that is equivalent to 5 cents. That is 0.05, not 0.5. If I have 1 dime, that is equivalent to 10 cents. And if I have 1 quarter, that is equivalent to 25 cents. So it's very important that you remember how much your coins are worth. If I have 6 nickels, that does not mean I have 6 cents. You have to remember that a nickel is worth 5 cents. So if I have 20 dimes, that doesn't mean I have 20 cents. You have to take into consideration that a dime is 10 cents each. You have to remember that when you're dealing with your coin problems here. So let me show you how you would set this up. Robert has some nickels and dimes worth $1.85. He has 11 more dimes than nickels. How many of each does he have? So remember, a nickel is 5 cents, which is 0.05, not 0.5. A dime is 10 cents, which is 0.10. You are going to have one equation for how much money you have and one equation for how many coins you have. There is a difference. So, for how much money I have, I am getting 5 cents, or Robert is getting 5 cents per nickel, 10 cents per dime, to get the total of $1.85. When you have your money total, that's when you're going to deal with how much money they are worth. Then it says he has 11 more dimes than nickels. That sentence right there is dealing with how many coins he has. So I don't need to include how much they are worth. So 11 more dimes than nickels means his dimes is 11 plus nickels, 11 plus n. This problem is set up for substitution. However, before we start, I want to show you a shortcut to get rid of your decimals, so you don't have to deal with decimals the whole time you're solving. I can multiply this whole top equation by 100, and by doing that, that's going to move your decimal place 2 places for all of these, which means I can actually write this as 5n plus 10d equals 185. That way, you don't have to deal with the decimals anymore. Just make sure if you do that shortcut, you multiply all 3 terms by 100. All 3 of them will be moved over 2 places. Now let's solve using substitution. Since d equals 11 plus n, I'm going to take 11 plus n and plug it in for d. When I do that, this becomes 5n plus 10 times 11 plus n, I'm plugging in that whole thing for d, equals 185. Next, I need to distribute. So the 5n stays. 10 times 11 is 110. 10 times n is 10n. And now I can combine like terms. 5n plus 10n is 15n. I subtract 110 on both sides, and 15n is equal to 75. When I divide both sides by 15, I find that Robert has 5 nickels. It asks how many of each does he have. So if he has 5 nickels, then I can plug this back into the original. 11 plus 5 means he has 16 dimes. When you're setting up number 7, be careful. You're going to have one equation dealing with the total number of coins, so something is going to equal 18. And then you're going to have one equation dealing with how much money you have. Remember, you only have to include how much the quarters and nickels are worth with your money equation. You don't have to do it with your 18, your coin equation. All right, last problem we're going to do on this video is number 10. On number 10, it says there are 1,728 freshmen and sophomores in a school. There are 3 times as many freshmen as sophomores. How many of each type are there? So I'm going to use F for freshmen and S for sophomores. If there are 1,728 total, then F plus S equals 1,728. There are 3 times as many freshmen as sophomores. So as sophomores tells me I'm going to multiply the 3 times the sophomores. This problem is set up for substitution. Since F is already by itself, I'm going to take 3S and I'm going to plug it in for F. When I do that, this becomes 3S plus S equals 1,728. Well, 3S plus S is 4S. And my next step is to divide both sides by 4. When I do that, I find that there are 432 sophomores. If there are 432 sophomores, then to solve for the freshmen, I can plug that back into the original. 3 times 432 is 1,296. You can always double check this by seeing if those two numbers equal your total. 1,296 plus 432 does equal 1,728, so it makes sense. So now that I've done the evens with you, I want you to go back through and try to set up and solve the odds. Remember to use my examples for help, and remember you can choose which method you want to use. If your variables are lined up, I would recommend using elimination. If you have a variable alone, I would recommend using substitution. But again, it's completely up to you.